Hello guys, welcome back to Math Zone African Motives. We are still on our integration, now working with question papers as a revision after the introduction. So just make sure that you watched the introduction of each and every integral from by parts, working with completing of the square, working with the trigonometric functions of the sine, cos, tan, and cot. We talked about this, so make sure that you just go back to the introduction. So this is April 2023 exam question number 2. We are given to determine the integral of y with respect to x, all right, whereby y is given on 2.1 as 1 over the whole of this part, all right. This is 4 marks for that. Okay, let us just write our integral. Remember, they are saying we must integrate y in this case, and y is given as this part. So it's the integral of 1 over the square root of 7 plus 6x, all right, plus 3x squared with respect to x. Okay, so we talked of these integrals. So I just want to give you a time to think which is the best integral that you're supposed to have, all right? So if you take a closer look, you see that this one is the one that we talked about of the completing of the square method from the quadratic expression. This one, we are going to apply completing of the square method. So we are going to complete the square. All right, let us just write complete the square. So in that case, we are going to apply the completing of the square method, whereby we are supposed to complete the square of the quadratic that you're given. So this is given as 3x squared plus 6x plus 7. Remember the format ax squared plus bx plus c, all right? And I told you that this is supposed to be 1, but there we are given a 3. So how can we make this to be a 1? We have to factor out that 3. So we factor out the coefficient of x squared, which is 3, so that we can divide 3 divided by 3, that's a 1. So it's going to be x squared plus 6 divided by 3, that will be 2. So you're going to have 2x plus 7 divided by 3, which is going to be 7 over 3, like this. All right. Remember what I told you guys, when you are at this stage using, this is traditional method. I'm going to also use the formula. Remember, I told you that there are 2 ways to use the traditional method or to go back to the formula. So using the formula at this stage, you are supposed to determine half the coefficient of x. This is our x here, which is 2x. So you determine half the coefficient of that x, then you square it. I talked about this, half of 2, which is 1, so it's 1 squared. So this square, we are supposed to add it and also subtract it on this expression. So this is it, 3 into x squared plus 2x. We add the square, which is the 1 squared, all right, plus 7 over 3 minus the square of 1. Okay, so this is it. So remember what I told you guys, you are working with this quadratic up to the 1 squared with the one that we added. But there we are not minding much, because what we are simply doing there is to simply factorize, but we are considering this part of x. The first and the last term, those are the terms that you focus with. So the first term being x and the last term being 1. These are the ones that you're going to have in your bracket. So you factorize the first, which is x, the last, which is 1 squared. Then the rest, you simplify it as it is. All right. So there, we're just going to need our calculator for the simplification. 7 over 3 minus 1 squared. This is 7 over 3 minus 1. Okay, let us see. 7 over 3 minus 1. Let us subtract a 1. This will be 4 over 3. That's a positive. All right. So it's going to be positive 4 over 3, like this. Okay, this is it. So I want us to check something here. We can expand by 3, multiply by 3 throughout. So that will be 3 into the bracket, which will be 3 into the bracket of x plus 1 squared. Remember, I told you 3 has got no access to be multiplied inside of the bracket, because there's an exponent here that is limiting us. All right, we are limited by the exponent there. But here we can multiply, plus 3 is going to multiply this 4 over 3, right? So that is going to be a 4. 3 times 4 over 3, guys. 3 times 4 over 3. You can even use the calculator, but this will cancel. You get what? You get a 4. So that is what we are going to have. So we have completed the square by using the traditional method. But I also said with this completing of the square, we can use the formula, which states that quadratic, all right, if I am given a quadratic expression in the form of ax squared plus bx plus c, all right, let's say I'm given a quadratic expression of ax squared plus bx plus c plus bx plus c like this. This is equal to, by completing of the square method, all right, let me try to reduce a little bit. By completing of the square method, this is equal to 4ac minus b squared. So this is 4ac minus b squared over 4a, all right, plus a into the bracket of x plus b over 2a. So it's x plus b over 2a squared. That's what I said on that introduction. I said this formula you ain't given. You are not given this. They're not going to give you this formula. They do not have that so far. But if we check with our previous exam for N5, all right, sorry for that, guys. I was saying, if you check with the previous exam of N5, you'll see that there's some of the introductions of the formulas that they are bringing in. So we just hope with time, we shall have this presented also in our formula. But for now, you're supposed to know it by heart if you are to use the formula. All right. So what does the formula states is that if you're given your quadratic expression in this form of ax squared plus bx plus c, which is the format that we have here, 3x squared plus 3x squared plus 6x plus 7, where this is our a, which is 3, our b, which is 6, our c, which is 7. We can write it as a completed square in this format, already factorized, right? So let us see. So this is going to be 4 times a. Our a here is 3, so it's 4 times 3 times c. Our c here is 7 minus b squared. Our b is 6, so this is 6 squared. Everything over 4 times a. Our a, which is 3. All right, plus a. Remember, our a is 3, so this is 3 into the bracket of x plus b over 2a. So this is going to be plus b over, oh, sorry for that, b. Remember, our b is 6, so it's going to be 6 over 2a. And our a there is 3 from our equation, from our expression, our a is 3. So you're going to have this squared. So this is what we are going to have. If you are to simplify this properly, of which we can have our calculator for the simplification. Let us just bring our calculator back so that you can see fraction. So here, just combine everything. 4 times 3 times 7 minus 6 squared. Minus 6 squared over 4 times 3. 4 times 3 like this. We are going to get a 4. So this is going to give us a 4 plus 3 into, so this is going to be x plus 6 over 2 times 3. This is 1, guys, all right? 2 times 3 is 6, and 6 over, which is 1 squared. Or you can just use the calculator. 6 over 2 times 3, which is going to give us a 1. So this is one and the same, or you can just simplify direct, as you can see. All right, so with this simplification, you can see that you're obtaining the same answer. It's only the different ways of presentation, but this is exactly the same as what we have. And I explained that on the introduction by completing of the square method, that you can use any of these methods, all right? So it's up to you which method are you going to use. But as you can see, we've got same answers that we have. We can even write it as the same way as the first part, starting with this. So it's going to be 3 into x plus 1 squared plus a 4. And this is exactly what we have here. But that is not the question. The question, this completing of this square is something that you're supposed to know. The question is on integration, not on completing of the square. After you have completed your square, we have to go back to our question here. This was our question. We are supposed to integrate this with respect to x. All right. This is what we are supposed to integrate. I'm just going to rewrite this side here. We are supposed to integrate 1 over the square root of 7 plus 6x plus 3x squared. All right. This is our question. That is what we are supposed to integrate, this part. So how are we going to integrate this? We saw that by completing of the square, this quadratic expression here, we got this part. So we're going to write this answer that we got after completing the square from the quadratic of 3x squared. This is what we got, right? And this is what we have, this part of 3x squared, whatever that we have. So you're going to write that answer 3 into the bracket of x plus 1, this and that. So it is the square root of 3 into the bracket of x plus 1 squared plus a 4 like this. So we are going to integrate this with respect to x. Okay. So I told you guys on the introduction, we talked about this actually. And I said, once you are at this stage, you are supposed to go back to the integrals. And let's hope I have got that. Guys, okay. I'm just gonna share. I'm just gonna try by all means to share that part, those integrals, so that we talk about them. We talk about those integrals together, guys. All right, let me try to share that part again. All right, so here I want you to see here. Okay, these are the integrals that I said. Once you are working with the completing of the square method, you end up with these integrals. From this integral, there is one integral that is going to match up to this integral at the end here. There's only one integral that we can use. Remember our question there, we are supposed to integrate, all right? We are now at the stage where we are supposed to integrate 1 over, remember that was 1 over 3. I'm just going to rewrite so that we can properly check together which one is best. How do you check it? Plus 4. So this was under the square root like this, dx. So you have to check of these integrals, which one is the best that you can use on your formula. Okay, so let's check the first one. There we have got a minus, so this one is totally out. Here we do not have a square root, so it's totally out. Here we have got a square root, but we do not have 1 over. This is 1 over. So this one is out. Okay, we move on to this one, dx over a squared. This one is out. We do not have a square root here. All right, we move on to this one. All right, let me reduce a little bit so that you can see our question also. We move on to this one. There is a square root, yes, but the format there, so this one is totally out. We do not have 1 over. All right, the last one is dx over the square root of b squared x squared plus or minus a. So this one is the best because we can write this 3 as a number to the power of 2. This x is already, the bracket is already raised to the power of 2. And they are saying plus or minus, meaning to say we can use a plus, we can use a minus. So this is the best formula that we are going to pick from these integrals that can be able to use, that we can be able to use to integrate this. All right, so I'm going to rewrite this formula on our question so that we can properly substitute together. All right, this was our question here. We saw the formula, guys, and I'm going to explain with that formula again. Okay, here we are. So according to the formula that we are given, we said, in fact, the formula is given as, this part, guys, we're not going to need it, all right? We have used this part, so let me just remove it because I want us to be together here, because most of us, we have a confusion on using these formulas. So that's why I want us to properly see the formula. So I'm just going to rewrite that formula. They are saying the integral of, if we are given 1 over, in fact they gave us as dx over. So the dx I explained from the previous from our introduction that it simply indicates 1 times dx. It gives us dx. So that's why you see there it's given as the integral of dx over the square root of b squared x squared plus or minus a squared. All right, like this is going to give us 1 over b. I'm just taking the formula that I showed you exactly as it is so that we can be together. The ln of bx, all right, plus the square root of b squared x squared plus or minus a squared. So this is what you're going to have plus the constant of integration. So if we check here, I told you that you need to rewrite in the way that you understand, like in this format, because this is the format that best suits here. So if we are to check, this can be given as 1 times dx, like I said, gives us dx, so it's same as we've got dx over, we are supposed to have the square root of b squared, which is a number. A b is just a number, a normal number. So there's a 3. How do I write 3 as a number to the power of 2 or to the exponent of 2? It is going to be the square root of 3 to the power of 2. I haven't changed anything. I just want to have it as this, b squared. X squared, already our x is the x plus 1. So there is x plus 1 squared plus, so it means if this is a plus, I'm not going to use minus. I'm going to focus with plus. Plus a squared, what is representing a is this 4. So it's going to be written as 2 squared, so that we have it as a squared. 2 squared is 4. We haven't changed anything. So this is the integral that we are supposed to have. So with the answer now, because of this format, we saw that the format is going to be 1 over a. Once it is written in this form, we can integrate this as this way. So the answer is 1 over b, whereby b, in this case, according to this format, this is our b, this is what part of the square root, this is our x, and this is our a from the 2 squared. All right, the x is the whole of this part, which is x plus 1. The b is the whole of this part, which is the square root of what? The square root of 3. So when we are given a condition like this, 1 over b, b is the square root of 3. So it's 1 over the square root of 3. All right, ln, in this case, bx, ln bx. So b is what? Square root of 3. So it is going to be ln the square root of 3, which is our b, times x. What is representing x is the whole of this part here, which is x plus 1. That is what represents x. Okay, so that is x plus 1. All right, plus b squared x squared plus a squared. Since there's a plus, we're going to take it as a plus here. This part here represents this part as it is, the square root of this part as it is. And this part here is the one that we took originally from here. We just rewrote from here in a way that is presented here. So this part, it's simply this part of the square root that we had before. So we simply write it in simplify, not to write this one now, we simply write as it was before on our question. So it was the square root of 3 into x plus 1 squared, all right, plus a squared, which is a 4 as it is. Even if you take it this one, remember square root of 3 squared gives us what? 3. X plus 1 squared is x plus 1 squared. 2 squared is 4. So still we're going to get this, all right? So no matter the way that you want to present it, still you are going to have the same answer, and plus the constant of what? The constant of integration. So this is how we're supposed to integrate this one. And there's nothing that you can do. As you can see, we can't simplify any further. So that is how you play around with completing of the square. You need to know your completing of the square. Either you are using the formula or you are using the traditional method of the completing the square to obtain this part. But after obtaining this, I told you guys that you need to know which formula to use to integrate whatever that you formulate. It's over this, is it over the square root? Is there no square root? You go back to those integrals that I showed you previously, which are these integrals. So from these integrals, one of these is going to work for your question. One of these, all right, from these integrals, one of these. So this is page 4 of your integral from your formula sheet. This is page 4 on your page 4. These integrals from this up to the last one here, these are the ones that you're supposed to use. One of these is supposed to, whenever you are dealing with what? A completing of the square method, unless that question can be used substitution method. It can be like that the question requires substitution method. That one you do not force to use this one, all right? So that was it, 4 marks for that. Okay, so let's check the second one. 2.2. Integrate x times arctan x with respect to x, all right? So that is what we have now. So that is 2.2. Let us just use this one. So is the integral of x arctan of x with respect to x, and this is 4 marks for that. Okay, which is fine. Which is fine. We talked about this also. Whenever you're dealing when there's a product of 2 terms, what you think about is the by parts. I told you on the introduction of by parts, product of 2. We are multiplying x and arctan. So what the best thing that you're gonna think about is by parts. Remember, by parts, it states that the product, if we are integrating the product of f of x by g prime x dx, it is going to give us f of x by gx minus the integral of f prime x gx. The formula is there in your formula sheet, do not worry. All right, so on this formula, f of x is something that we can be able to differentiate, and it's difficult, in fact, for us to integrate arctan. So it is best for us to choose arctan to be our f of x, because we can't like integrate this part. All right, so if our f of x is equal to arctan x, therefore g prime x dx, which is the remaining part, is what is remaining here, which is x and what? And dx. So this is what you're gonna have, and g prime x dx is what is remaining here, which is arctan. All right, so this is arctan x dx. So remember, I told you from f of x, what is it that you're going to find? You're going to find its derivative, f prime x. So we are going to need f prime x from arctan. All right. From arctan, let me just try to show you with the formula sheet if we have this together, or I'm just gonna write it. But I just wanna see if I have it. Let's check here. The integral of arctan, how do you integrate that one from your formula sheet? All right, I think I left the page. All right, let me just write it down, because I think I left out the page when I was inserting the formula sheet. All right, I think it's here. Yeah, the arc is here. Yes, it's here. These are derivatives. Sorry, these are derivatives. All right, these are derivatives, not integrals. I left it, no problem. So let me write it down. Okay, here is where we are. So if we are to differentiate, this is derivatives, guys. Why am I skipping this? I have it. I saw it here. Here. All right. Arctan here, the derivative, exactly this. We need the derivative exactly here. This is exactly what we want. The derivative, because that is f prime. F prime is the derivative, all right? So the derivative of arctan is here. Arctan f of x. So arctan f of x is the first derivative of f of x over f of x squared plus 1. So there it was given as arctan x. So our f of x is x. That is our f of x. So on the formula, we are going to need f prime x. The first derivative of x, which is the first derivative of x, is what? It's 1 over f of x squared. Our f of x is x. So it's going to be x squared plus 1. So this one is going to give us 1 over x squared plus 1. All right. So it's going to be 1 over x squared plus 1. After integrating everything, we have used the formula direct, guys. I'm not going to redo this. I think you understand me. from that part. If you do not understand, let me know so that we can see other ways of explaining it. All right, so let me go back to my page. Sorry for that. All right, here so we've got a lot of things, guys. You see your Maths N6, guys, it has a lot of things. You have to go to this page, this and that, so that you properly see. But anyways, I hope you see what I'm trying to do. So we differentiated this arctan. Even arctan for you, you're supposed to know it, just to know the arctan. All right. Anyways, we saw this is gonna give us 1 over x squared plus 1. Okay, so this is it. Then from the g-axis, the g prime, we integrate both sides. Guys, what am I doing? What am I doing here? Why am I saying this is arctan? This is x. This is x dx. X dx like this. All right. You integrate both sides for x. So what are you going to get? We are going to get gx here, which is equal to the integral of x. So the integral of x with respect to x is going to be x squared over 2. So there we are going to have x squared over 2. So let us get back to the formula and substitute. So it means the whole integral of this part that we are having here is going to be equal to f of x, whereby f of x we said it's arctan. So this is going to be arctan x by gx. We are now substituting by gx, which is x squared over 2. So this will be x squared over 2 minus the integral of f prime, which is the first derivative of f that we got here. So this will be 1 over x squared plus 1 times gx. Remember, this is our gx, which gave us x squared over 2 with respect to x. So this is what we are supposed to have in actual sense. Okay. For this question is an interesting question here because, okay, let's simplify. What are we going to have here? Arctan x times this x over 2. We can just write as x over 2, x squared over 2, right? So you're going to just have it as x squared over 2 arctan of x. Okay, which is fine like that. Minus here, we can take out the 1 over 2. This is x squared over 2. So we can take out the 1 over 2 that is affecting our x squared here. So that will be 1 over 2 out of the integral. Then we are left with x squared times 1, which is x squared over x squared plus 1. All right, that is with respect to x. Remember, this is integration by parts. Whatever that you do here, you apply your by parts formula like what we've done here. We applied our by parts. We are now at this stage. I told you guys on the by parts that at this stage, you figure out what is appropriate for you to integrate. I don't know what is appropriate there. It's up to you. You have to figure out. All right, but if you go back to our mathematics N5, there was a condition that I talked about where the exponent and the exponent, the denominator and the numerator have got same exponent, which are the same, or a condition that the numerator has got a higher exponent. What were we doing in N5? We were applying long division. So meaning to say, to integrate this part, we are supposed to apply long division here. So this is going to give us what? All right, we're going to divide by x squared. So we're dividing. So that is x squared plus 1 into x squared, which is our numerator. All right, so let's divide. X squared divided by x squared, which is 1. Remember, from your long division, you multiply back. So it's going to be 1 times x squared, which is x squared, 1 times 1, which is a 1, which subtract. All right, x squared minus x squared, that's a 0. All right, here it's same like there's a 0 here, so it's 0 minus 1, which is minus 1. So meaning to say, after dividing, we are getting a 1 and a remainder of minus. The remainder, there's a minus, we write minus 1 over what was dividing. We were dividing by what? By x squared plus 1. So by long division, this is what we are going to have in this from this part in simplest form. So meaning to say, we are going to have the integral of this. We are going to have this as x squared over 2 arctan of x minus 1 over 2, the integral of, instead of us integrating this because it was going to be challenging, we take this now in simplified form, which is going to be the integral of 1 minus 1 over x squared plus 1, x squared plus 1 like this. So this is what we are supposed to integrate with respect to x. All right. So we applied long division in order for us to have this. Now we are at this stage. How are we going to integrate? Is it possible for us to integrate 1? Yes. What about to integrate 1 over x squared plus 1? Is it possible for us to do that? That is now the question. Is it possible? Okay, we talked about the formulas that are important. All right, okay, let's expand. I'm just going to talk about those ones. Let's do it stage by stage. Expand this, we're going to have 1 x. So let's write stage by stage so that we do not confuse each other. Arctan of x minus 1 over 2. Let's integrate. The integral of x of 1 with respect to x is going to give us x, okay? Minus, what is going to be the integral of 1 over x squared plus 1? In actual sense, guys, we were supposed to go back to the normal approach that we had before. We use those integrals that I told you before, those integrals, these ones. Let me show you these ones. We pick which one is the best identity, which one is the best integral to use. But guys, if we consider what happened here, remember integration is the reverse of derivative. Integration is the reverse of derivative. 1 over x squared plus 1, this one, was obtained where? Where did we obtain 1 over x squared plus 1? We obtained it from arctan. So instead of, yes, if you do that, you're going to obtain the same answer as this one, which is arctan x. But instead, guys, you see that reverse. That's why we have to consider those things again. Integration is the reverse of what? Derivative. So it means we are just reversing. The integral of this gives us what? Arctan. If the derivative of arctan gives us this, it means the reverse, the integral. If I integrate this with respect to x, I get arctan. So this is exactly what we have here. 1 over x squared plus 1, which is the same as what we have 1 over x squared plus 1, which was taken from what? Arctan x. So here we are going to obtain arctan x. All right, so that's arctan x plus the constant of what? Integration. So the question is, someone is asking, what if I wanted to use the formula? Yes, we're going to use the formula. Let us just prove with the formula. Let us just prove with the formula quickly. 1 over, remember the question is 1 over x squared plus 1. We are supposed to integrate 1 over x squared plus 1 with respect to x. So let us check for the formula. Which formula is best? Where we're given 1 over this. All right. The first one is out, so there's a square root. The second one, yes, the second one is best. It's actually the 1 because it's dx over a squared. But here I'm just going to write in this way, a squared plus this. So it will be like this. It will be the integral of 1 over 1 plus x squared. All right. All right. In actual sense, we're supposed to have as x squared like this. All right, with respect to x. So in order for us to have a squared, it means, remember I told you 1 is same as 1 squared, does not change. B squared, if the number is not there, it means also there's a 1 squared. X squared, already the x is already given as x squared here. So this is exactly what we want here. So from this one, the answer is supposed to be 1 over b. We are now integrating 1 over ab. So it's 1 over ab. Remember, our a is 1, our b is 1. This is a, b, x. So this is a, b, and x. So it's 1 over 1 times 1 over 1 times 1. arctan bx. So this is arctan. Our b is 1, so it does not change. 1x is 1x over a. Our a is 1, so it's just 1 like that. So 1 and 1 cancels, it's a 1, so it's just going to be arctan x. So that is it. So this agrees together that we are in the same concept. You could have used those identities of the integrals, or you could have just reversed because you saw that this is not familiar. It's something that this is something that is new. It's something that I worked with before. So I just take the answer. Okay, so that's it. We are done. We can leave our answer at this stage as it is, or you can even expand the brackets if you want. So this is going to be x squared over 2 arctan of x minus 1 times x, which is going to be minus of x minus minus. This is going to be a positive, so it's positive half arctan x like this plus the constant of integration. So at this stage, there's nothing that we can do. Yeah, there's nothing that we can do at this stage. We can't do anything. We can't combine anything. Just have to leave it like that, right? Just have to leave it like that. We are done. So these are the stages that you're supposed to have. Just have to be careful on how to simplify. You have to be very, very, very careful. The use of your laws, the use of your integrals, whatever that you are given, how to use it, how to apply it. You have to be very, very careful whenever you're simplifying. And also you check some of these ones. It's just something that we already had from our N5. So it's just a continuation. All right, let's check the other question. 5 marks for that, which is in this case was to integrate cot. All right. So this is 2.3. The integral of cot to the exponent of 5 of 7x with respect to x. So if you check properly, you will see that this is a question that we had a similar question on our introduction, if I'm not mistaken. This one, we had this one. Okay, anyways, I said for cot and for tan, whether it's to the exponent of an even number to the exponent of an odd number, we are supposed to split this from the identities of cot and tan, which we are going to have as cot squared ax is equal to cosec squared ax minus 1. Remember, that was the identity that we said we're going to use. So if it is to the exponent of 5 like this, we have to expand until, guys, we have to expand until we can integrate. Okay, let's do this stage by stage. All right, let's try to minimize so that we can see everything properly. All right, this is it. I think we can be able to see everything. I hope you can be able to see this. Okay. So in order for us to have a cot squared, it means we are going to have the integral of cot squared to the exponent, cot squared 7x, all right? So this is cot 7x squared, okay? Then I told you that for a cot and a tan, you do not raise to the exponent of 2 like this, then you write another cot 7x so that you say, this does not happen for cot and for tan. It only happens when you are working with a sine and a cos. That's where you raise to the exponent of 2. But for a cot, you write the other as it is, which is you're going to write cot to the exponent so that we get a 5. The other one is going to be cot to the exponent of 3 of 7x with respect to x. Okay. So at this stage, this can be taken to be equivalent to cosec squared because we have an equivalent identity for that. So we can substitute that as cosec squared. So this is going to be cosec squared ax, which is our a, there's 7. So it's going to be 7x minus 1. Close the bracket. That will be cot to the exponent of 3 7x with respect to x. So remember, what are we supposed to do? You're supposed to expand the brackets, all right? We expand this, we multiply by cot inside. So this, if we multiply on this side, it is going to be the integral of cos x squared, and there's a cot. So we're going to have the integral of cos x squared 7x and also a cot. So this will be cot to the exponent of 3 7x with respect to x. Then there's a minus 1 times this. So we're going to write this as minus outside of the integral. Then it's just cot. So this will be cot to the exponent of 3 7x with respect to x. And I say that in a normal question, they can even ask you that integrate this. This part that you see here, it can be a question in another exam. They can even ask you to integrate this. So it means you are supposed to go back again and rewrite in terms of cot squared, just like the previous case. We are supposed to expand it again. So you expand and expand until the last part where you are supposed to integrate. So let's expand again. So here we are done. There's nothing that we're going to do. We can integrate that, just rewrite as it is. So it's going to be cos x squared 7x cot cubed 7x with respect to x minus the integral of cot. So this was supposed to be expanded as cot squared 7x times cot 7x, so that it gives us cot to the exponent of 3, 2 plus 1, 2 plus 1, that will be a 3. Okay, the bases are the same. So meaning to say this cot squared is the one that we want. Cot squared 7x is equal to what? Cos x squared. This is the equivalent. So we are going to substitute cos x squared 7x minus 1. But there's a cot 7x that is there also. So remember that. So this is going to be cot 7x with respect to x. All right. So instead of you rewriting this, you can just go to the stage direct. All right. It's a product of these two. Then as we are focused on cot squared, so you have expanded again, but we are back again to the brackets where we have to expand our brackets. So we are back here, expand the brackets. Like I said, this one you just rewrite as it is, the integral of cos x squared, the integral of cos x squared 7x. All right, cot cubed 7x with respect to x minus, all right, so here we're going to expand this cot into the bracket, all right, but there's a minus that is already outside. So it's going to be minus the integral of cosec squared 7x times cot. So it's going to be cot 7x. We move on here, minus and minus 1 is going to be a positive. So we're going to have the positive, the integral of cot, because cot is also going to multiply inside the bracket. So it's going to be cot 7x with respect to x. But for this, it is a positive because there's a negative also outside of the integration sign. So this is where we are. And as we can see here, there's nothing that you're going to expand again. This can be integrated. This can be integrated. This can be integrated. So at this stage, we are done. But as usual, we see that we are back again to the usual part of the substitution method here. These two, we can get rid of the cosec squared 7x if we let u to be cot 7x, if our u is cot x. So on these two, I'm saying on these two, only on these two. So we are going to choose our u to be cot 7x. So if our u is cot 7x, the derivative of u with respect to x for cot is going to be -7. Remember, cot changes to cosec squared. So it will be cosec squared 7x. The number here multiplies, it's a negative. Then we make dx the subject by substitution method, guys. So it's going to be minus du over 7 cosec squared 7x. Okay, so meaning to say, on your substitution, because this is substitution method, on your substitution, you are going to substitute back. You are going to substitute back this part. So instead, guys, of substituting back each stage by stage, okay, you see that this is -1 over 7. So -1 over 7 is going to multiply out of the integral, -1 over 7. the integral of cosec squared. The cosec squared and the cosec squared here will cancel. The cosec squared 7x in the because it is in the denominator, so it will cancel with this one. Meaning to say we are just going to be left with cot. And this is cot, which is represented by what? By u. So it's the integral of u to the exponent of 3 with respect to u this time, because we are replacing dx. Okay, we move on to the same thing here, because these two, they are using the same method by substitution, and they use the same u. So meaning to say the answer is going to be the same. So minus 1/7, if it multiplies this minus that is outside, it is going to be a positive. So it's going to be positive 1/7. The integral of cosec squared, just like this part, the cosec squared 7x will cancel with this cosec squared, and this one, it will cancel, meaning to say you remain with cot x, cot 7x. But what represents cot x? Cot x is represented by what? Is represented by u. So it's the integral of u with respect to u, just like the previous case. All right. Then here we can integrate our cot, but let us just rewrite as it is, the integral of cot 7x. Here there's nothing that we're going to do. This part has nothing to do with the substitution that is happening between these two. No. Okay? Do not confuse yourself on that part. Okay, now let us integrate, guys. This will be minus 1/7. The integral of u to the exponent of 3, we add 1. So it's going to be u to the exponent of 4/4 plus 1/7. The integral of u, this is already a 1. So if we add a 1, it's going to be u squared over 2. All right, so you're going to have a squared over 2 like that. All right, plus the integral of a cot. From our formula sheet, let us just hope I have this part. Okay, let me try to show you guys the integral of a cot. How do you take the formula? I'm going to rewrite it again, but I want you to see how do you take it. All right, I just hope we have it here. Cot, do we have a cot here? A cot, the integral of, sorry for that. Sorry, where is this thing now? Where is it coming from? Where is it coming from? Where is it coming from? Cot. Where is a cot? Okay, guys, here, a cot is this one. Yeah, the integral. These are the integrals. If we check here on top, integral and integral, this one on top here. So the integral of cot ax is this one. 1/a, the ln of this part, and so forth. This is cot, not cot squared, but just cot as it is. So I'm going to take this integral as it is, all right? So let me go back. I just wanted you to see that you are using your formula sheet, all right? Everything is there from the formula sheet, all right? So everything is there from the formula sheet. So you just have to know how to apply, how to use your formula sheet in general. All right, so we saw that the integral of a cot is given, and is given as what? All right, I'm just going to rewrite aside so that we move together. We saw that the integral of a cot was written like this. In fact, the integral is not there, but they just wrote cot. As we know that we are integrating cot, and it's cot ax with respect to x. It was given as 1/a. So I'm just going to rewrite so that we move together. The ln of the sine ax, the sine of ax, plus c. All right. So if we take a closer look, we have a cot here, and this is cot 7x. Our a, it's a 7, so we are supposed to get 1/a. So it's 1/a, of which our a is 7, so it's 1/7. All right. The ln of what? The ln, so we're gonna have the ln of sine ax. So this is sine ax, which is 7x. So it's sine 7x like this. Okay, plus the constant of integration. So that's it. On this part, we have to substitute u back. Remember, u is represented by cot 7x. U is cot 7x. So wherever we see a u, we see a cot. Okay, we see a cot 7x. So this is going to be minus 1/7 times 1 over 4, which is minus 1 over 28. It is going to give us minus 1 over 28. Like I said, u is represented by a cot 7x. So it is going to be cot to the exponent of 4 of 7x. All right, you do the same, you multiply 1 over 7 and 1 over 2. So if you multiply 1 over 7 and 1 over 2, you get 1 over 14. So that will be 1 over 14. U is represented by cot 7x, but there's a squared there. So it is going to be cot squared 7x. All right. And this part, there's nothing that we're going to do. Just have to rewrite as it is, plus 1 over 7, the ln of sine 7x, plus the constant of integration. There's nothing that you're going to do on that part. We cannot simplify that part any further. We are done with our integration. So the integration, it's an interesting topic. If you are that person who love to play around with calculations, then it can be a deadly topic. If you are someone who is just a little bit affected by the numbers, the way big they are, the way they get bigger, because for your N6, I promise you guys, you need energy for your syllabus. You need energy because these are the questions. As you can see, one question it will be like this in exam, and it will be 4 marks, because yes, they can write 8 marks, but it will be 8, they divide it by 2. So you look at the stages. So you need energy. You need also to be patient enough. After a certain stage, don't quit to say, I'm done, because you think that the steps are enough. No, the steps, they won't be enough. All these stages, they are marked. They mark all these stages. Sometimes you see a half mark, sometimes you see a 1 mark, half mark. So every stage, that's why I'm indicating these stages, they are needed. All right, so this is how you play around your integrals. And there are so many methods that you have. We shall see them as we revise our question papers. We still have a long way to go together. So I'm hoping that we're going to have a long way to go together until our exams. All right, number 2.4, it was an integration again. All right, of sine, and I think didn't we do the same question? Or it was on the introduction. I think this question was there on the introduction. Yeah, this question was supposed to be there. Anyways, let's do this. 2.4, the integral of sine, this is sine to the exponent of 4. So this is the integral of sine to the exponent of 4x with respect to x. All right, remember a sine, we said for a sine and a cos, if n is equal to an even number, if n is an even exponent, whenever you are dealing with a sine and a cos, there's a specific identity that you're supposed to use. For sine, you are going to use this identity. Sine squared ax is equal to a half minus a half of cos 2ax. I explained this identity also. If it is a cos, it becomes a positive here for a cos, all right? But for a sine, it's a minus. So meaning to say we are supposed to write this, we are supposed to write this in terms of what? A squared, sine squared. So this is going to give us the integral of sine squared of 4x. All right. Now I want you to be careful, because I was saying if we check what was happening all along on cot, we had a cot here, and I said cot is not like cos or a sine where you can write cot, you can't write cot to the exponent of 7x like this, then to the exponent of 2 times cot 7. You remember I was talking about this. So now it's an advantage because we can see it. We have got a sine. And like I said, for a sine and a cos, it's very, very possible. It's limited only for a cot and a tan. For a cot and a tan, you expand and expand and expand and expand up to the last part where you can integrate. But for a for a cos and a sine, you write this as to the exponent of 2. So it's sine squared 4x like this, everything to the exponent of 2 with respect to x. So what it means is that I'm going to substitute what represents sine squared 4x, right? So our a here is 4, here our a is 4. So this is going to be 2ax, which means cos 2ax. So if you multiply 2 times 4, it is going to be 8x. So meaning to say we are going to have a half. All right, sorry for that. We are going to have a half in this case, minus a half again. Then this will be cos, instead of cos 2x, is 2 times 4. 2 times our ax, which is 4x. So 2 times 4x. So it's like this, 2 times 4x, which is going to be 8x. So that will be cos 8x. So you have to be careful on this one. And it's being squared. So we are going to square this with respect to x. All right. I talked about the introduction, not the introduction, this expansion of these two, the squared, from the identity of a minus b squared. Remember, I said this, you're supposed to know it by heart. At least if you understand this, it's going to be easier for you. We say this is going to give us a squared minus 2ab plus b squared. So from this part, what it means is that we have got our a. This is our a here, the number. All right, sorry for that. Let me just use this one so that we can properly see what I'm trying to say. We have got the number here, a, and this is our b. Everything that is being raised to the exponent of what? That is being raised to the exponent of 2. So our a in that case is what? Our a is a half. Our b, this is a minus b, our b is this part. So it's going to be a squared, all right? A squared. So that is going to be a squared, which is a half squared. 1 over 2 squared, which is 1 over 4, right? So that is 1 over 2 squared, a squared, which is going to be 1 over 4. Okay? Just like 2 squared, 2 times 2, 1 over 2 times 1 over 2, right? So this is what we have. So anyways, let's move on to the other part. Minus 2ab, so it's, what does it mean? It means it's minus 2 times a. Remember, our a is a half. So this is a half times b. Our b is half, cos the part that I shaded here. So it's half cos 8x, that's your b. So you're going to multiply this and this cancel. So it's going to be minus half. So you're going to remain with minus half cos 8x. All right, cos 8x. Then the last part is of b squared, which is the last term squared, which is b. The last term, which is our b in this case, is this part squared. So if we square this, 1 over 2 is going to be 1 over 4. If we square this, it's going to be 1 over 4. If we square cos, it is going to be cos squared. So this will be cos squared 8x. So we have squared everything. It's like this, squared. You square everything. You square 1 over 2. You also square x. You also square cos. So that is how you can use this identity from your algebra. Or you have to expand your brackets properly. You do them stage by stage. Guys, it's up to you. It's up to you on that one. All right. Now let's integrate, because this can be integrated. We can integrate 1 over 4. The integral of 1 over 4 with respect to x is going to be 1 over 4x. All right. So this is going to be 1 over 4x minus 1 over 2, the integral of cos 8x. Remember, if you integrate a cos, it changes to a sine. So this is going to be sine 8x over 8. Okay? So this is sine 8x over 8 plus, here we are supposed to have the integral of cos squared 8x. So what is it that we get? All right. Do we have this one? Did I insert this? All right, let me check if I inserted this or not. If not, I'm just gonna explain. I think it's here. All right. No, it's not. I didn't insert it. No problem. I forgot to insert this. All right, no problem. So I'm just gonna write this so that you understand. So from your formula sheet, if you check, there is an integral of cos squared. If you check properly from your formula sheet, it must be page something like page 3 for cos. It must be page 3. All right, on your formula sheet. you check it's written as cos squared. So I'm just going to put the integral, but there is not, the integral is not there, but I'm just going to put the integral. So it's the integral of cos squared ax with respect to x. What is important is that here there is ax. All right, so let's put this in bracket. So whenever you're given this integral of this nature, use the formula sheet. All right, so on your formula sheet is given as x over 2 plus, make sure you are with me on your page 3, sine 2ax, everything over 4a plus c. This is our formula. All right. So with this formula, it's going to be easier for us because it's just substituting. Our a is 8. So it's going to be x over 2, right? Which is going to be x over 2 plus sine 2ax. Our ax is 8x. So it's 2 times 8x, 2 times 8, which is 16. So it is going to be sine 16x. Everything over 4a, which is our a is 8. So it's 4 times 8, which is 4 times 8, which is 32. So that'll be 32, right? So that's it. We have integrated everything like that. That's how we integrate plus the cost of integration. Just like that, we have integrated. So you see, if you understand your formula sheet, it is going to be much, much easier if you understand your formula sheet. So at this stage now, what you need is to expand and simplify together. Okay, let's just expand the brackets. Here is going to be 1 over 4x. We can multiply 2 and 8, which is 16. So it's minus 1 times sine x on top. It's sine 8x over 2 times 8, which is 16. Okay, we multiply this plus 1 over 4 times 1 over 2. This is same as 1 over 2. So it is going to be 1 over 8x. Right here, we multiply 1 times sine 16x. It is going to be sine 16x over 4 times 32. So if we multiply 4 and 32, we are going to get 128. So that's something like 128, okay? Plus the constant of integration. So if you expand now, you can properly see that these two are supposed to be combined. There's x and x there. And I told you that on this case, do not forget, do not be tempted just to underline your answer to say I'm done. No, these are like terms. There is x, there is also x. So what do? You have to add these together, combine these terms together. All right, so let us combine and see what you're going to have. So if we add 1 over 4 plus 1 over 8, because there's x and x. So if we add 1 over 4 plus 1 over 8, we're going to get 3 over 8. So that will be 3 over 8. So this is 3 over 8x. All right. Then the rest we're just going to write as it is minus 6 sine 8x. So this is sine 8x over 16. All right. Remember, we combined these two, so it's now a single fraction. We're going to move on to this one plus sine 16x. So this is sine 16x, everything over 128. All right, plus the constant of integration. So this we can even write as minus 1 over 16 times sine 1 over 28. It's up to you the way that you want to present it. But that is how you're supposed to integrate this. And it got all the marks by doing this. Just like that. So you see, it's like there's a lot of things, but it's nothing because everything is there in your formula sheet. You need to know your stages and how to operate from your formula sheet. If you can know how to operate from your formula sheet, we are done. All right, anyways, let us check the last question that we're given, which is on 2.5. So on 2.5, we are asked again to integrate. This is tan. All right, why are they giving us something like this? This is something that is direct. All right, anyways, the integral of tan x over 2 like this with respect to x is because I did not insert everything from the formula sheet. But from the formula sheet, you see that the integral of tan ax, the integral of tan ax like this with respect to x is going to be given as, this is, let me check the page, but it's 1 over a. I'm going to check the page for you. 1 over a ln sec So this will be like this, ln sec ax, sec ax, all right, plus the constant of integrate. That's how you integrate a tan. So if you check on page 2, yes, on page 2 of the formula sheet, I want you to check on page 2 of your formula sheet. There a tan is given as 1 over a ln sec ax plus a constant. So meaning to say, here it was just a normal application because it's 1 mark. So in order for us to properly see the a, we're supposed to write this properly. This is the same as 1 over 2. 1 over 2. All right. Here it's 1 over 2. 1. This is our a. So our a there is 1 over 2. So if we are given this, it's going to be 1 over a, which is 1 over 2. So it's supposed to be 1 over 1 over 2 like this. All right. Ln sec of ax. Remember I said a is 1 over 2. So it's going to be 1 over 2x. All right. Plus the constant of integration. So 1 divided by 1 over 2 is 2. So it's going to give us 2 ln of sec half x like this. All right. Plus the constant of integration. We are done. For 1 mark, guys, for 1 mark, this is enough. We can't use like a lot of things there. So that was it, 18 marks. Like I said, they do ask this question, they do ask this question. So I'm explaining much because I know they do repeat these questions. So once you understand what I'm explaining right now, you will see that you can answer as many questions as you can. They do repeat the format. What can just change is that this year, this question paper, it was a 4x. Next one is going to be 3x. Another one, they will put 2x. Another one is just going to be x. This was cot to the exponent of 5, 7x. Another question paper is going to be 5x. Another question paper, they will just put cot to the exponent of 5 of x. They just change. They just change like that. So as you do more question papers, you'll be able to understand the mind of the examiner. And this is what we want to do as we are revising. So let us just hope for more questions to come.